Hi, I'm Michael Pfeiffer from Industrial Metallurgists. In this video, I discussed the failure analysis of a cracked chuck that was cracking during its fabrication. This is a companion to the article on our website about the same thing. So in this case study, or in this failure analysis, we were trying to determine the root cause of the cracking of the chuck. So the chuck was made of a 13.8 pH stainless steel. It was made from wire. A hole was machined in the wire through the entire piece of wire. Then a slot was machined in the component. And then the material was sent for a heat treatment. It was for age hardening. So it was heat treated at 900 degrees, which is called H900. And the purpose of this heat treatment, or during the heat treatment, small particles form in the metal. These particles are called precipitates, and they strengthen the alloy. The strengthening resulted in a hardness that was greater than 53 Rockwell C. So it was a high hardness, high strength heat treatment. After the heat treatment, then there was subsequent processing, and during the subsequent processing, the chucks were cracking. There was about 30% fallout. So there was a lot of money being put into these chucks, only to have to throw out 30% of them because of the cracking after the heat treating. And the cracks were forming at the end of the machine slot. So for the failure analysis, we did scanning electron microscopy of the crack surface, also looked at the microstructure, and measure the hardness of the material. And looking at the scanning electron at the fracture surface and at the microstructure, we determined that the material was failing in a brittle manner. The heat treatment that was used, H900, results in high strength but also poor fracture toughness for the material. That means it has a high susceptibility of cracking where there is a stress concentration, and this machine slot was a stress concentration. So we recommended using a different heat treatment, heat treating at a higher temperature that resulted in slightly lower strength but better fracture toughness to improve the resistance to forming a crack after the part was heat treated. That indeed worked. So even though there was lower strength after the heat treatment, the improved fracture toughness was okay, and the lower strength was also okay. And the result was that there were no longer any cracking of the component after the heat treatment. So this is an example where failure analysis was used to collect information that was helpful for determining the root cause of a quality problem. If you'd like to learn more about failure analysis, you can take our course, go to our website, and look at the Metallurgy courses page of our website, and you can see the course on failure analysis. And of course, we also help with failure analysis, and that information is also on our website. So if you're having a quality problem or component reliability problem, reach out to us and we can help you get the information you need to quickly determine the root cause of the problem so that you can move on to doing other things. Thanks for watching, and good luck with your metals. Bye.